Okay, so I stopped the recording because I'm going to put the first lecture as the introduction for your course, and then I'm going to put the second recording for our subject matter. Although we only have about 29 minutes left, but we can actually progress quite a bit for this part. The first chapter that we have is actually is the measurement chapter. The measurement chapter actually handles with some very basic concept. First of all, we have to understand what we mean by scalar quantities, and then what do we mean by vector quantities. Important bit. Scalar quantities are those which can be exclusively expressed by numbers, which only have magnitude, and their absolute value can be at minimum 0, whereas vector quantities have both magnitude and direction. The change of vector quantity can happen by the either change of any of those properties, magnitude or direction, or it can happen by the simultaneous change of both. You are going to come across a lot of different quantities in your whole syllabus, and you have to know precisely which of these variable, which of this quantity falls in which category, which one is scalar and which one is vector, and something else. You have to know this derivation. For example, force is a vector, but mass is not. Mass is a scalar quantity. Velocity is a vector quantity. Speed is a scalar quantity. Then let's say density is a scalar quantity. Specific heat capacity is a scalar quantity, whereas gravitational field strength is a scalar quantity. Magnetic field strength is a scalar quantity. Sorry, gravitational field strength is a vector quantity. Magnetic field strength is a vector quantity. So you will come across all of this quantity, and every single time a new quantity comes up for a certain chapter, I'll tell you what type of quantity is that. These are the very basic two quantities that we teach for your level, but the actual idea for the dependability of direction actually goes further beyond that, which is not required for your syllabus. And this is also another topic that's called tensor. Tensor is a far-fetched idea for your level, so এটা নিয়ে তোমাদের মাথা ঘামানো লাগবে না। আমি জাস্ট একটা জিনিস বলি যে প্রেসার, তোমরা কি প্রেসার পড়ছো স্কুলে?
Yes, sir.
Okay, pressure is a quantity. Pressure is defined by what? Pressure is defined by force over area. এখন প্রেসার কিরকম কোয়ান্টিটি, এটা কিন্তু ভেক্টর, সেটা আন্ডারস্ট্যান্ড। দিস ইজ এ ভেক্টর কোয়ান্টিটি ডিভাইড বাই স্কেলার কোয়ান্টিটি। সো এই রেশিওটা লজিক্যালি ভেক্টর হওয়ার কথা না?
Yes, sir.
কারণ তুমি এটা যদি দেখো, ফোর্স ইকুয়ালস টু মাস টাইমস অ্যাক্সেলারেশন। তো অ্যাক্সেলারেশন হচ্ছে একটা ভেক্টর, ফোর্স একটা ভেক্টর। সো তার মানে হচ্ছে কোনটা সার্টেন একটা অবজেক্টের উপর আমরা যেদিকে ফোর্স অ্যাপ্লাই করবো, তার অ্যাক্সেলারেশন ডিরেকশনটা ওইদিকেই হবে। সিমিলারলি তুমি যদি অ্যাক্সেলারেশন ইকুয়ালস হচ্ছে ডেল্টা ভি ওভার টি, এটা জাজ করো, টি হচ্ছে একটা স্কেলার কোয়ান্টিটি, তার মানে হচ্ছে চেঞ্জ অফ ভেলোসিটি ডিরেকশন যা হবে, অ্যাক্সেলারেশন ডিরেকশনও তাই হইতে হবে। সো এরকম হচ্ছে টিপিক্যাল রিলেশনশিপগুলো হয়। এখন কথা হচ্ছে প্রেসার ইকুয়ালস টু ফোর্স বাই এরিয়া। এই ইকুয়েশনের মধ্যে ফোর্স হচ্ছে একটা ভেক্টর, এরিয়া হচ্ছে একটা স্কেলার কোয়ান্টিটি। তাহলে লজিক্যালি প্রেসার একটা ভেক্টর কোয়ান্টিটি হওয়ার কথা না?
Yes, sir. But it's scalar, right?
কিন্তু প্রেসার কিন্তু ভেক্টর কোয়ান্টিটি না। এখন কথা হচ্ছে প্রেসার কিরকম কোয়ান্টিটি, লেট মি শো ইউ। প্রেসার কিরকম কোয়ান্টিটি সেটা নিয়ে তোমাদের ডিটেইল ডিসকাশন নাই। আমি তোমাদেরকে দেখাচ্ছি এই জন্য যে টু গিভ ইউ দ্য কনসেপ্ট দ্যাট quantities can be not only scalar or vector. There is more than that scope in the actual discussion part. So what type of quantities? It says pressure, therefore pressure is a scalar quantity, not a vector quantity. Okay. Okay, pressure is defined as a scalar quantity. এখন আমি টেন্সরের ডেফিনিশনটা তোমাদের দেখাই দিছি না, বিকজ আই ডোন্ট ওয়ান্ট টু স্কেয়ার ইউ অ্যাবাউট ফিজিক্স, সো ডিসরিগার্ড দ্যাট। ওটা পরে কোনো সময় ডেনসিটি প্রেসার চ্যাপ্টার যখন আসবে তখন দরকার হলে দেখাবো না। সো বেসিক্যালি দিস ইজ দ্য বেসিক ডেফিনিশন ফর স্কেলার এন্ড ভেক্টর। এটাতে শুধু ম্যাগনিটিউড থাকবে, আর এটাতে ম্যাগনিটিউড প্লাস ডিরেকশন দুইটাই থাকবে। The next thing that we have to understand from chapter 1 is the different name of the prefixes. For example, কোন প্রিফিক্সের সিম্বল কি, কোন প্রিফিক্সের ভ্যালু কিরকম, সেটার একটা নোট আমার কাছে ছিল, এটা মনে হয় আমি খুঁজে পাইতে পারি। Please help me find that. Yes, got it. এটা তোমরা তোমাদের প্রিন্ট আউটের মধ্যে আশা করি পাই যাবা, সো ডোন্ট বদার। এই আচ্ছা, there are also quantities are also defined by two other things, সেটা একটা হচ্ছে যে বেস কোয়ান্টিটি আর হচ্ছে ডিরাইভড কোয়ান্টিটি। Base quantities are there are 7 definite quantities which are defined as base quantities, which are given over here: length, mass, time, temperature, current, luminous intensity, and amount of material. Out of these 7 quantities, we are not going to handle all the 7 quantities for our O-level syllabus. You don't have anything to do with luminous intensity, which comes in your AS level for the cosmology chapter or astrophysics. And amount of material is not going to be introduced for your O-level physics, but you do know what mole is from your chemistry. Do you guys know what a mole is?
Sir, not here.
Yes, sir.
Achha, for those who don't know, I'll tell you what a mole is. Mole is basically the amount of a certain substance in terms of how many. For example, 2 of any object can be called a pair. 4 of any object in Bangla can be called a hali. 12 of anything can be called to be a dozen, right? So certain number of things has a specific name. Similarly, if you have any object in this many number, that is Avogadro's constant 6.02 into 10 to the power 23. If you have anything of this many numbers, that is basically 1 mole of that object. For example, if somehow I was photocopied this many times and all of us would be in one place, maybe we'd call them 1 mole of Faisal sir. If we have this many hydrogen molecule, we're gonna say this many hydrogen molecule is 1 mole of hydrogen gas, so on and so forth. So how many, by count, how many, that's a way to measure a certain object, and that method of measurement is what we call amount of material. Its SI unit is mole, unit symbol is MOL. Symboler মধ্যে শুধু ই টাকা বাদ দেওয়া হয়েছে। মোলের কনসেপ্টটা বুঝছো?
Yes, sir.
কতগুলো আছে, এটা হচ্ছে মোলের বেসিক কনসেপ্ট, হাউ মেনি। এখানে এই ডেফিনিশনগুলি দেওয়া আছে, ডেফিনিশনগুলি তোমাদের লাগবে না, ডেফিনিশনগুলো আমি জাস্ট দিছি তোমাদের, জাস্ট ইফ ইউ আর ইন্টারেস্টেড টু লার্ন অ্যাবাউট দোজ থিংস, ইটস আপ টু ইউ। And then we have some examples for derived quantities. Any physical quantity which is not a base quantity is a derived quantity. Derived quantities are those which are obtained from the multiplication of multiple different scalar quantities, multiplication or division of multiple different scalar quantities. For example, area is given by length into length, volume is given by length into length into length, density is given by mass by volume, force is given by mass into distance divided by time squared, mass into acceleration. Acceleration is actually what? Distance over time squared, meter per second squared, that is. So everything which is not a base quantity is a derived quantity. If you wonder why do we have to make this distinction, because for the sake of easier working of the whole physical world, we prefer not to devise new stuff for every single thing, because every single object is defined to be unique. So there are certain quantities which are defined to be unique, and you can use those units, or you can use those quantities to express other quantities. So that's why 7 of these quantities are defined as base quantities, and all the other things are defined in terms of these quantities, because physical world is actually related to each other. So you can pretty much say that these 7 base quantities are sort of like the letters of the alphabet, and we make words with the whole alphabet with multiple different combinations. So we have the whole language thing. So that's basically physics world, such and so on and so forth. The next thing that we have is the power. One of the important thing that I actually wrote over here, that quantities have different symbols to be used in mathematical equation, and the units have some symbols too. Do not mix them up. For example, physical quantity work uses the symbol W, capital W, in the equation. The unit of power, watt, W-T, also uses the symbol capital W. Now, before getting confused in this, you need to understand that one is a symbol for a quantity, and the one is for unit. You will find the differences much vividly when you study these individual topics. Just in case, equation of work done is given by W equals to Fx, and watt is used like this. The power of this machine is 1000 watt. So you shouldn't mix up these 2 letters. So these 2 type of expressions. Same letter can be used in multiple cases. And one other thing is that capitalization can also vary in a lot of cases. For example, have a look over here. Sometimes capital letters and small letters mean different. For example, symbol of power is capital P and small p is the symbol of momentum and pressure. Now there is no hard and fast rule whether you can or cannot use capital P for pressure. You can use capital P for pressure. No one is gonna bug you, but I'm showing you the way your Cambridge book is working out this variable. Symbol of volume is usually shown by capital V, whereas small v is a symbol for velocity, or to be more precise, final velocity. Symbol of resistance is given by capital R, whereas small r is typically the symbol for radius. These are some general symbols, but we can always have a variation of this. For example, in the case of gravitational rule, we use R for the measurement of distance. Small r is used for variable distance. Capital R can be used for the radius of a planet. So they can have different usage in exclusive cases, but in many cases there the capitalization can be somewhat different. And here comes a much bigger list of this whole thing. You don't have to know this whole list. I just put it over here because I had access to this information. This is the part that I'm pretty much interested. The part that is shaded over here is the amount that you might require to know for your syllabus level. And then the part that is, those are in white. These are just something that why does it read DF? It's supposed to read micro. What is wrong with this thing? What? I don't know what happened here. This is supposed to read micro. Format painter. Save as PDF. Save. Overwrite. Can't overwrite. Close. Retry. Good. So the shaded part is also wrong. I need to color these boxes in shadow, which should be this color. A bit lighter. Okay. Same. Sorry kids, আমি কিছু এডিট করতেছি তোমাদেরকে বেকার বসায় রেখে, কারণ এখানে কিছু ছোটখাটো মিস্টেক ছিল। Get it out of the way. Okay. Page layout, as a document, center, new. Save. Okay. That should work. So what we have over here is that these are the individual symbol for the different multiplier values. So you don't need to know about hecto or deca. These are not anymore used quantities. 10 to the power 0 is given by 1. Deci is 10 to the power minus 1. Centi is 10 to the power minus 2. Milli is 10 to the power minus 3. Up till now, we have a decrement by an order of 1. So to the power minus 1, to the power minus 2, to the power minus 3. The symbols are all in small letters. From the milli, if we go downwards, then we have a decrement of in the order of 10 to the power 3. So for milli is 10 to the power minus 3, which is 0.001. Micro is 10 to the power minus 6, so which means 0.5 zeros and then 1. Then micro, beyond micro, you have nano and pico. This is the part up till which you should know for your O levels. So these symbols are all given in small letters. Whereas if we go for the upper level, we have kilo, which is 10 to the power 3. Then we have mega, 10 to the power 6. Giga is 10 to the power 9. Then we can have all the way up to here. I actually collected this list from the Wikipedia, I think. You don't need to remember this all the way. So the part that is shaded over here, this you for your syllabus level volume, remembering this much is good enough. But then again, if you want to remember all the other parts, you can. No big deal. Knowing a bit more information doesn't never hurt. So important information is that for the bigger part, we always have the capital letters, except for kilo. Kilo is written by small k. not capital K. Capital K is a symbol for Kelvin. Kelvin is the temperature unit for temperature, dynamic temperature, that is. So mega is capital M, giga is capital G, and then tera, peta, exa, zeta, iota, it all goes up. Where is that thing where I actually wrote about that Kelvin thing? Yeah, cautions. Have a look at this thing, these two bullets. Don't ever write kilogram to mean kilogram. Don't ever write capital K, small g to mean kilogram. You see, kg is the unit of mass, not kg. Capital K, small g would mean Kelvin gram, and that is wrong. So keep a good watch on writing capital letter or small letter. And then also keep proper alignment of letter and their exponent, power or index while writing the units. Kilogram per meter cube, unit of density, must be written as kg meter upore to the power minus 3, not like kg meter minus 3 or kg meter minus 2 upore 3 টা হচ্ছে একই level. So the horizontal alignment matters whenever you're writing these things. Just be careful from the very beginning so that you wouldn't be making a mess whenever you go for later on. প্রথম থেকে কেয়ারফুল থাকলে পরে এই জিনিসটা ডিফিকাল্ট হবে না, বাট ইফ ইউ ডেভেলপ দ্য হ্যাবিট অফ ইট ইন দ্য রং ওয়ে ফ্রম বিগিনিং, দেন পরে গিয়ে এটা কাট করতে গিয়ে তোমার অ্যাডিশনাল এফোর্ট দেওয়া লাগবে। সো জাস্ট বি কেয়ারফুল অ্যাবাউট দিস স্টাফস, স্মল স্টাফস, বাট স্মল স্টাফস ম্যাটার। এই হচ্ছে ফার্স্ট চ্যাপ্টারের হাবিজি। ফার্স্ট চ্যাপ্টার থেকে আর কঠিন কিছু নাই, দ্যাটস বেসিক্যালি ইট ফর দ্য ফার্স্ট চ্যাপ্টার। অ্যাডিশনালি আর কিছু ইনফরমেশন আমাদের ফার্স্ট চ্যাপ্টারে আসে যেগুলো অ্যাকচুয়ালি আমাদের ল্যাবরেটরির জন্য লাগে। সেটা হচ্ছে one of the things is that how does a vernier caliper work, and how can we take reading for the vernier calipers? How does a micrometer screw gauge work? How can I take reading from a micrometer screw gauge? I'm not going to teach you those things in today's class. I prefer not to teach those things in the first classes. I usually prefer to directly jump into the kinematics and the motion stuffs from the very beginning. So I'm going to keep those things paused for the time being, and eventually whenever we'll be solving some MCQ paper, because in the MCQ paper we have a lot of MCQs regarding those two components and other measurement techniques as well. We're going to see about those things in those chapters after a while. So I'm going to keep it paused for the time being. Then if I go over here, what we have for the second chapter, আচ্ছা তোমাদেরকে একটা জিনিস দেখাই সিলেবাস থেকে। Might as well download your actual syllabus, why not? Which oh, got it. Okay, what we need is syllabus. May June 2020 October normal, and then we have all the class papers. What is this? Does this also have the syllabus in it? Maybe they do. আচ্ছা, সিলেবাসে নামানোর জন্য তো সিআইতে গেলেই হয়। এই তো এখান থেকে ডাউনলোড করলে দেখা যাচ্ছে, ওদের জন্য পাপাকে বেজে গেলাম। সো তোমরা পরীক্ষা দিবা হচ্ছে 2023 তে। Syllabus start download, it's complete. So okay, they have given the wave. This is the visible spectrum, beep gear, and then we have the upper part, we have the lower part. No, nice animation, nice three-dimensional vector diagram. What I am trying to look for is the first and the second chapter. Okay, these are the 6 specific topics that we go by. First one is motion forces and energy. The second one is thermal physics. Then we have wave. Then we have electricity and magnetism. Together they make one topic. Then we have nuclear physics, and then we have a new thing which is called space physics. I usually used to teach electricity and magnetism differently in 2 different topics, but here I can see that they have combined these 2 topics, electricity and magnetism, together, which is perfectly all right, no big deal. We can handle that. The grouping really doesn't matter. The content pretty much remains the same. There are small bits of changes every once in a while in the syllabus, and we can have a space physics. I need to find out what the space physics is about. Okay, this was the first chapter. Then we have the motion. And now for this chapter, they have actually given you the whole motion chapter in a single heading. But earlier they used to have two different chapter named kinematics and dynamics differently. They're just two different aspects of the force related and motion related topics. And you have all the stuffs over here. If you don't have a syllabus, you should download this, and every once in a while you can go around in your syllabus to find out that which of the points actually look unfamiliar to you. For example, let's say by the time we have finished the second chapter, which is the motion thing 1.2, and some other relevant stuffs which will come along with it, for example, mass and weight, forces and forces continued, and not turning effect of force up to circular motion, we're going to become covering within this part. I actually am not going to go by the exact formation that this one is arranged by. Wow, they have included momentum in your O-level syllabus. This is very beautiful. Love it. I did not see that earlier. Good, very good, nice. So anyway, আমি যে পয়েন্টটুকু বলে আজকে ক্লাস শেষ করতে চাচ্ছি, আমি সেই পয়েন্টটুকু আগে বলে শেষ করি, নাহলে পরে দেখা যাবে যে 9টা বেজে গেছে, তোমাদের তুলনা ক্লাসের টাইম হয়ে গেছে, আমি তোমাদেরকে ছেড়ে দিতে পারতেছি না, কারণ আমি তোমাদেরকে এনাফ পরিমাণ পড়াইতে পাইনি। So I just try to get there. Chapter 2 তে আমাদের এক গাদা ডেফিনিশন আছে। First of all, the definitions that we have to understand is distance and displacement. What do we understand by these two things? Then we have speed and velocity. Then we have acceleration. And then we have force. What do we mean by force? We also have to define what do we mean by mass. And then weight is also a type of force, so might as well write it over here. And that's basically it for the definition parts. Distance is a scalar quantity which is defined like this: the amount of path traveled by any object is defined as distance. It is the length of the path that any object takes. So if it's a curved track, if an object goes from here to here, the length of this total track is the length of this curved line is the distance covered. Whereas displacement is a vector quantity which is defined as the linear distance, important term, the linear distance from the starting position towards the final position is the displacement any object makes, irrespective of the path. So if an object is starting from here, its aim is to reach over here. If it goes over there by this path, the displacement is going to be the straight line that joins these two dots in the direction from the start to the end. If the object made its travel through a different path, maybe through a path like this, or maybe through another path like this, or maybe it went through some other path, but if the starting point and the final point, these two are defined and they are same irrespective of the traveling journey path, you are going to have the same displacement. But depending upon your individual different path, you can have different distance traveled. So for example, let's say if I'm going from Chittagong to Dhaka, my displacement would be exactly the same no matter how I travel. Land, air, or water, doesn't matter. I can choose to use different form of travel on the land. I can choose to go by personal car, I can choose to go by bus, I can choose to go by some other method, bicycle, whatever. Displacement will be same, but distance covered can be different. The least amount of distance obviously would be if I travel by flight, because that's a straight line pretty much. And then rail can have some other distances. It's also quite straight, but not that straight. Point is that displacement is a straight line distance that goes from the starting point to the end point, whereas distance is the amount of path which depends upon the track or the shape of the path that we have taken to go from one place to another place. Speed is the rate of distance covered, which is a scalar quantity. Velocity is the rate of displacement made, which is a vector quantity. Now, velocity can have a whole lot of different variety in it. For example, for a certain amount of movement, we can have a term that's what we call average velocity. Average velocity means that total displacement, total displacement divided by total time. For some cases, we can use instantaneous velocity. Instantaneous velocity. Instantaneous velocity basically means what is the exact immediate velocity at a certain time instant. So, for example, one of the good ways to explain in instantaneous velocity can be like this. Let's say there is a car. We are not drawn to scale, standing in a traffic signal, and the signal turns to green. And if you're trying to draw the VT graph of the car from the instant the light turns to green, so t equals to 0 means that the green light has just flashed up. That's where t equals to 0. So what usually happens that the car actually stays 0 at for some time. That's what we call the reaction time of the driver. And then the driver actually presses onto the accelerator. The whole mechanism of the car starts to work, and then the car starts to accelerate, and then it will reach a certain speed. And at a certain beyond a certain velocity, if the driver is driving safely, it might actually get a constant speed for a certain limit within city limits, or within countryside. You can have different speed limits and so on and so forth. So what is the exact speed at a specific time instant? That's what we mean by instantaneous velocity. So you can have it for at this time instant, you have one velocity which can be read off from the y-axis. At some other times, you can have another velocity. So different time instances can give you different instantaneous velocity, and they can be in this case I'm trying to show you that the car was supposed to travel in a straight line, where this is only showing you the variation of magnitude. But sometimes you can also have variation of angle as well. For example, if you have an uniform circular motion, let's say there is an object that is going around in a circular motion with uniform speed, but it is going in a circular path, which means every single instant it's undergoing some amount of direction change. So this velocity and this velocity, let's say v1, and this is v3, where this one will be v2. Each of these velocities are individually different. They might have the same magnitude, but they don't have the same direction. So this actually causes acceleration because there is change of velocity happening. So that's the implication of scalar and vector quantities in the crude term that which we have to work through as our discussion goes on. Acceleration is the rate of velocity change, which can come in the form of magnitude change versus time, which can also happen by direction change versus divided by time. For most part of your mathematical solving for your syllabus will be mostly handling the magnitude variation. So for most part of your acceleration equals to del v by del t, we will be handling the magnitude change. So we'll consider the object is moving in the same straight line, either speeding up or slowing down, or maybe going in the opposite direction compared to where it's in which direction it started. But for most part, we'll be working with magnitude change. So we'll not be working with direction change for calculation part for your syllabus. But there can be some vector diagrams in triangle rule where I'm going to show you some specific vector diagrams which can give you some insight for how can we handle or how can we possibly calculate or measure velocity changes that is attributed from the direction change as well. Force. Before I define the term force, I don't have much time, maybe 30 seconds. Any definition can be given in two different ways. One type of definition is what we call the qualitative definition. The other type of definition is what we call the quantitative definition. For example, force can be defined. It is a pull or push on any object. That's what we call a qualitative definition. Whereas the quantitative definition for force can be said it is the product of mass and acceleration of an object, or you could say it is the rate of change of momentum of an object. That is a quantitative definition. As per your CIE syllabus, yeah, the examiners prefer quantitative definitions more compared to qualitative definitions. So we're going to try to adopt quantitative definitions in as many cases as we can. Weight is defined the force by which Earth pulls something. The exclusive gravitational pull of Earth is defined as weight, and mass is basically how much substance does an object has. Massের actual definition টা actually দিয়ে আমরা দিয়ে হচ্ছে inertia দিয়ে. So massের definition টা আমি এখন ডিটেইলসে ঢুকতেছি না, massের definition টা আমি next class পড়াবো, আর next class আমি time graph নিয়ে আলাপ করা শুরু করব, because the first thing that I always teach within this chapter is graphs, how to manipulate graphs, how to handle graphs, how to extract information, and I mean graph কি পুরো ভাইজা খায় ফেলা যাও বোঝায়. I'm going to take 2-3 classes to make full sense of the graph things, and we'll pick it up in the next class. It's 9 p.m. Your 2 class is now, so গুড বাই, গুড নাইট, আসসালামু আলাইকুম।
স্যার।
তোমাদের ভিডিও আমি একটু পরে আপলোড করে দিব, আর হচ্ছে প্লেলিস্ট লিংকটা আমি তোমাদেরকে পাঠিয়ে দিব, তোমরা ওখান থেকে চাইলে দেখে নিতে পারো। আল্লাহ হাফেজ।
আল্লাহ হাফিজ।
স্যার।
আসসালামু আলাইকুম।